Now we will discuss about a topic called wedge. Wedge is nothing but a simple lifting machine. Why it is called as lifting machine? Before that, what is mean by wedge? Wedge is nothing but a wedge is made up of a metal or wood, any shape. It may be of two different shapes. It may be of triangular shape or maybe of trapezium shape. It may be of two shapes where the opposite faces all will not be parallel. It means in triangle the opposite surfaces will not be parallel. That means if we consider this triangle where these are the opposite faces, these faces will not be triangle. That is wedge. Wedge is used to lift a body with the application of less amount of force. With this application of less amount of force, the effect on the body will be more. Suppose in the wedge friction there will be involvement of wedge. There it is a wedge. Generally the weight of the wedge is neglected. Whatever the wedge, this is the wedge. Wedge may be of two shapes. They may be of triangular shape or trapezium shape. And consider a body. I have to lift. To lift the body here shown is which I have to lift. A load or any body which I have to lift. To lift this body with the help of wedge, place initially at this tip of this tip is point is shown as O. Initially the wedge should be placed at this tip. By the application of forces, this must be carried out on the surface. They are resting on the surface. To move this wedge, it means whenever I apply a force P, due to this application of force P, the wedge will be moving in this forward direction. Due to this forward direction, this wedge will be in contact with this down support, that is nothing but where it is laying, and to the body to which it is attached, or the body which should be raised. It is attached with the two surfaces. If you see, I will consider this as A, and another this is as C, and this is as B, and this is D, E, and F, and G. If you consider this, for this forward movement of P, it means the P, whenever a load P is applied, the wedge will be moving in this direction. Whenever the wedge, for this movement of wedge, the load will be moving in this direction. If you see, whenever the P is moving in this direction, whenever it moves, if you see, the inclined portion is moving towards left side. Whenever the inclined portion is moving towards left side, this body will be moving upside. It means for this horizontal movement, we are having the vertical movement. That is the principle of wedge. The principle of wedge is whenever you apply a force horizontally, the body will be lifted vertically. If the P force is enough to move this wedge, then this wedge has the capacity to lift the load up. Okay, whenever this P force is necessary, or if P force is necessary to move this wedge, then it indicates that this wedge has the capacity to move this body or to lift the body. Here the use of wedge is, why we need to use wedge? Instead wedge, why can't we use other machines? Because wedge is a simple machine. It is of negligible. Here the weight of the wedge is generally not considered. Weight of the wedge is generally negligible. Okay, and whenever this force P is applied, this will be in contact with these surfaces and another these surfaces, and this load body will be in contact with these two surfaces. Whenever this force P is applied, this wedge will be moving towards left side, and this load or body whatever we have placed on the wedge, it will be having upward or downward movement. For horizontal movement we are having the vertical movements, or for the horizontal motion we are having this particular vertical motion. It means that whenever a body is moving, it is in contact with the ground surface AC and contact with the body. Here if we consider this wedge, however the weight of the wedge is neglected. Now the forces acting on this particular wedge, whenever we consider this particular wedge, if you see, the forces acting on this particular wedge are, here the force P is acting on the wedge, and whenever this wedge moves in this direction, friction always acts opposite to the applied force. Here the applied force is in this direction, then the friction will be developed in this direction, which is opposite to the force. However, there will be a normal reaction generated whenever it is in contact with the supports. I assume that the friction developed is of F1 and the normal reaction generated will be of N1. Okay, whenever I take the resultant of these two forces, I take this resultant is as R1 which is making an angle of phi 1. This angle is phi 1, which is the resultant. R1 is the resultant of this frictional force F1 and N1, which is the normal reaction. And next it is in contact with this surface also. If you consider this surface, here it is in contact, therefore there will be a normal reaction generated normal to the surface. Here also normal reaction to this AC is also generated normal to the surface. Here there will be a reaction generated, that is the normal reaction. I am considering it as N2. Okay, their normal reaction is generated and there will be a frictional force generated whenever the wedge moves in this direction. Okay, if you see the wedge moving in this direction, the frictional force which is present here will be held in this direction, opposite direction. It means the frictional force is in this direction, F2. Then there will be a normal reaction or the resultant reaction will be generated. That resultant reaction is, I am considering it as R2. Okay, this is then it will makes an angle of phi 2. I am considering it as phi 2. Okay, here phi 1. Always the resultant makes an angle only with normal reaction. Here is also normal reaction. This angle is called angle of friction. This phi 1 and phi 2 are said to be the angle of friction. And considering this angle as alpha, I am also considering this angle as alpha. If you see this angle, if this angle is alpha, then this angle also will be alpha. Okay, now if you see that due to this N1 and F1 we got the resultant R1, due to this N2 and F2 we got the resultant R2. If we draw this, here is a point where we have applied a force P. If you see that there is a normal reaction and a friction, due to this both we got a reaction R1. Okay, if you see this, there is a reaction R1 which is making an angle of phi 1. And if you observe that there is a normal reaction R2, due to this normal reaction and friction we got another one that is said to be R2. Here there is another force, that is normal reaction making an angle of alpha. Here this is making an angle of phi 2. Okay, if you observe that, if from the Lami's theorem we can state that, what is Lami's theorem? If three concurrent forces, coplanar concurrent forces, the force is equal to the angle between the other two forces ratio. If P by the angle between the other two forces is, here this R1 and R2, we have to find this angle. If you see that this total angle is 180 degrees, if we minus this, if we subtract these two angles, we get the angle between the other two forces, that is P into sine of angle between the other two forces. Sine of total angle is here is 180. 180 minus phi 2 minus alpha minus phi 1. That is phi 1 minus phi 2 minus alpha. And the other force acting is R1. R1 next, the reaction. It means the angle between these two forces. Opposite forces are these two forces and the angle between them. Now the R1 by sine of this angle is, already this angle is 90 degrees. 90 degrees plus phi 2 plus alpha. 90 plus alpha plus phi 2. And next one is resultant R reaction R2. R2 by, here the angle between the other two forces. These are the angle between the other two forces. However, this is 90 degrees. This total is 90 plus phi 1. Sine of 90 plus phi 1. We can find this P force whenever we equate these two forces. Okay, this is the way to find what is the application of force P. Now here we consider only the equilibrium case of wedge. Here if we see that the weight of the wedge is neglected. Now next we considered about the equilibrium of this particular body. The body is in contact with this particular wedge and this particular surface. Therefore the normal reaction will be generated from both the surface DG and from GF. Okay, if we draw this, here the load or body is acting. but in the case of here, what is see wedge, the weight is neglected. But coming to this body, here the weight also will be taken into consideration. Here I am considering normal reaction is acting N3. Whenever for this forward movement, this is having an upward movement. Therefore, the friction will be generated in the downward direction, that is F3. Okay. Due to this N3 and F3, there will be a resultant reaction will be generated. I am considering it as R3. However, you know that the angle of friction is the angle made by the resultant with the normal reaction. I am considering this is as phi 3. And next, the normal reaction which is acting are here. When we place this body, this both should be cancelled. Nothing but the here the normal reaction is nothing but acting, which is N2. Whenever this moves in the upward direction, the body is moving in which direction? In the upward direction. If we see that for this forward movement, the body is moving in the upward direction, or in other way we can say that the body is moving upward. For the upward movement, the friction will be generated in the downward side. Therefore, the friction will be generated which is of F2. And therefore, there will be a resultant reaction generated. I am considering this is as R2. The angle between these two is, however, we know that phi 2. Okay. Now, this is the way to solve. Now we know that here the angle is, which is the angle which is of alpha. Okay. Now I want to solve this by taking the equilibrium equations. Now what are the equilibrium equations acting on? Here there are only two forces acting. The vertical forces must be equated to horizontal forces. If we see that whenever this is reduced to here R3 with the horizontal direction, it makes R3 cos phi 3. R3 cos phi 3. This must be equal to here R2. Here about x-axis, if you see about y-axis, it is, if you see this angle, this is of angle alpha. How this angle is alpha? To know that, here if we consider a wedge, here if you see alpha, whenever I draw a normal here, if you see, whenever I draw a normal here, it will be 90. This angle will be 90 minus alpha. If this angle, this total angle should be 180. Then what about this angle? Okay, 180 minus 90 minus alpha, that is 90 plus alpha. This angle is of 90 plus alpha. However, I have already drawn a normal to it. Then when we subtract out of 90, it means this angle should be 90. Then the remaining angle is alpha. In this way, we got this is as alpha. Okay. Now, whenever this normal reaction is resolved, here, sorry, this, where is this resultant is resolved, R2 cos alpha plus phi by 2. Here, in the x direction, in the y direction, we get cos. In the x direction, we get R2 sin of alpha plus phi 2. Okay. And next, when we resolve this, R3, next in the horizontal direction, now in the vertical direction, this will be resolved to R3 sin phi 3, and the weight is also considered here, that is in the downward direction, plus W is equal to, now in the vertical direction, if we resolve this, what we get? R2 cos of alpha plus phi. It is little bit confusing too, I think so. If we draw this, the total here, which is of R3, which is making an angle of phi 3, and a load W is acting, and there is another force which is of R2, which is making this total angle is of alpha plus phi 2. Alpha plus phi 2. If we resolve this, this is R3 cos phi 3, and in the downward direction R3 sin phi 3. Now R3 sin phi 3 plus W. R3 sin phi 3 plus W. Now I want to resolve this. Here in this direction R2 cos of alpha plus phi 2, and in this direction here if you see R2 sin alpha plus phi 2. Now we got in the vertical direction, and when we apply the equilibrium equations, we get that. If you are confused with this, try to see this. Okay, this is the, in this way we will solve the problems.